Right, I'm assuming you can, you can hear me, that's fine. Right, awesome. 4 minutes, less than 4 minutes, 5 slides, I'm gonna make it really quick. My name's Nick, I'm the CEO and co-founder of Mission Zero Technologies, and I'm here today just to give you a bit of insights into some of the things that we've learned, some things we've discovered through deploying direct air capture systems in real-world, commercial, industrial environments with customers, and give you a kind of glimpse of what the future looks like and what we're actively working on at this moment in time. So here you have a render of our third system in a nice hypothetical environment with lots of solar cells. Isn't that great? This is the future we could all have if climate change wasn't coming to slowly bake us all to death. So direct air capture, I think this conference has quite a strong focus on the CDR side of things. But from our perspective at Mission Zero, direct air capture is a all-purpose technology that simply generates a high-quality source of CO2 that can be used for a variety of things like building materials, fuels, removals, yoga mats, pharmaceuticals, alcohol. You know, we can pretty much turn anything in the world that we need. We can pretty much turn CO2 into anything that we want to. We've got the ways of doing that. So we just need the ability to get out of the atmosphere, and that's what we think direct air capture is. So this is our first system. It's a relatively small system, 50 tons per annum. It is a 20-foot shipping container, all contained within, which we deliver to the University of Sheffield for the production of synthetic aviation fuels. It's not a massive system. It's not intended to produce large volumes of fuel. What it is intended to do is provide the University of Sheffield the capability to say, if we create this fuel and we test and verify that it's safe to use, the UK can all of a sudden start to scale out the use of synthetic aviation fuels, or SAF. So that's what we're going to do here. Contract delivery was in 10 months. This is actually a UK CA and CE marked product. So it has the same safety certifications as an iPhone, like little pastiche, little demonstration there. And we learned a lot through doing this about defining, managing scope boundaries with customers, their particular needs on site, things like this. Next system, this is for deployment into building materials. Customer with OCO technology in the UK, funded by the UK government. It's currently going through commissioning. We've achieved a 50% reduction in installation time compared to that first system. So again, every time we do this, the idea is we get it on the ground, and we iterate, we learn, we make it faster, we make it better. This is actually located on the site, so it's providing an on-site source of CO2 that is then turned into building materials, pavements, roads, asphalt, et cetera, et cetera. So not only are we locking the CO2 away for a long time, but you're also creating value and creating the built environment around you. So we think that's really cool. A little bit more about the system. Next to it is a huge dog food factory as well, right? So I've got a laugh over there from Nicholas, right? So that's fine. So one of the other cool things about this is we're going to get to test in a real-world environment where there's like dust flying around, cement. There's probably going to be dog food in this system as well, right? So like, you know, this is about just like putting it on the ground and pushing it so hard that it might catch fire or burn, right? That's a little bit facetious, but the idea here is let's figure out what it looks like to actually make this reality, get the learnings, and then go from there. And, you know, you're not asking for ideal situations here, but the realities of delivering on the ground. And then you will have seen Phil DeLuna yesterday talking from Deep Sky. We were one of Deep Sky's portfolio companies. We're delivering on site. We're currently going through the deployment phase of this system at this moment in time. We are, if I can get the laser to work, here we go. We're this system here. It looks a little bit nicer than just white, but I think Deep Sky's rendering here is very, very cool. Nice thing here is compared to that first system I showed you, I've run out of time. I didn't want to run out of time, but I've run out of time. I'm going to make it really quick, promise. We've achieved a 60% reduction in levelized cost here from a CapEx perspective as well. So we're able to come down the cost curve every time we do this. We're making it efficient. And one of the cool things we're able to do here is engage local labor and supply chains close to customer sites, so we can actually make DAC economically advantageous for the local communities that are involved in deploying and building it. So lastly, we're now working on our next generation system. This is a 1,000-ton per year system. This tends to be a system that we can say, if you want to buy it, it's ready for us to deploy with you. It's the same core processes and equipment as our first commercial deployments, but because we've gone through all the iterations, we now know what it looks like. It integrates early cost reductions, energy efficiencies, and material optimizations, and it's informed by real-world operational experience and data, and we will have more to say on the system in due course. Thank you.